Hi, and welcome to this video on solving quadratic equations by factoring. In this video, this is one of several videos that I'm going to make on looking at different ways to solve quadratic equations by factoring. Okay, so the first way we're going to talk about is the longest way, and that's factoring by grouping. Remember, we learned this a while back, and a lot of people like to use this because it's a guaranteed way that you can find out whether or not your quadratic equation is actually factorable. Okay, so in factoring by grouping, one of the things that we need to do is we need to be given the equation in standard form. So in this case, we have ax squared plus bx plus c is equal to 0. So that means that in order to factor or to solve a quadratic equation by factoring, we need to have a y value of 0, which means that the graph is crossing the x-axis. And of course, on the x-axis, the y value is equal to 0. Okay, so now let's look at how to factor by grouping. Where our rule tells us that we're looking for two numbers, m and p. So we're going to try to find those two numbers, given that the two numbers m and p should add up to b. So I'm going to write m plus p should add up to b. And in this case, if we look at our coefficients for this function or equation, f squared plus 12f plus 36, a would be 1, b would be 12, and c would be 36. Okay, so m plus p should be 12 in this case. And m times p should be equal to a times c, so that would be 1 times 36. And so in this case, that would be 36. So now let's try to figure out what these two numbers are. Well, we want the numbers to give us a positive 12. So if I think about my factors of 36, I'm going to look at the factors of the product of m times p. Okay, well, 6 and 6, if I add those together, would give me 12. Well, are there any other factors of 36? 9 and 4? No, 9 plus 4 won't give me 12, so that one can't work. And of course, 1 and 36, even if I added a negative and a positive, that still wouldn't give me a 12 in the middle. So my numbers have to be 6 and 6. Okay, so a positive 6 and a positive 6. And since both terms are positive, or all of the terms are positive, then I know that both of those sixes will be positive. So now I'm going to rewrite the original function in this form. So ax squared plus, and instead of bx, I'm going to separate them into my two new terms of m and p. So plus mx, which is 6x, plus px. Actually, I'm not going to put the numbers in yet. I'm just going to rewrite it in the form that it should be in. So ax squared plus mx plus px plus c is equal to 0. So now let's rewrite it, putting in our new coefficients. So our coefficient of a is the same. So x squared, 1x squared, plus 6x, plus 6x, which was my px, plus c, and c stays the same, which is 36, and that's equal to 0. Okay, so now I'm going to group. Okay, so I need to group my terms together. Well, if I look at it, I'm going to group where I can pull out common factors. Well, if I look at x squared and 6x, it looks like they both have an x in common, so I could pull that out, which means that I would have to group the other two together. And it looks like they both have a 6 in common, so I could pull that out. So let's do that. I'm going to put brackets around x squared plus 6x. And then I'm going to put brackets around 6x plus 36. You don't want to include the middle term, or the sign on the middle term. You don't want to include the addition sign, because the addition sign should not be in the parentheses. Okay, so we're going to factor out. The addition sign just tells us that we're adding two binomials together. Okay, so it's not multiplication. You don't want to put the parentheses around that, because then that would make it multiplication. So let's factor out the common factor in the first binomial. So I have x squared plus 6x, and they both have an x in common. So I'm going to factor out x, and so I'm going to be left with x plus 6. And then in the second binomial, I'm going to factor out a 6. And inside, I'm going to be left with x plus 6 again. And so I'm going to set that equal to 0. Well, if you look here, in both binomials where I factored out a term, I'm left with x plus 6. Okay, so I'm going to pull that term out. So now I have two separate terms which each include the same binomial of x plus 6. So that's a factor. X plus 6 is a factor. So it's almost kind of like I'm pulling out by a factor of two factors. So I'm pulling out x plus 6 out of the two factors I have, x times x plus 6 times x plus 6. So x plus 6 is now a common factor. And what's left, if I pull out an x plus 6 in each term, is another x plus 6. And so that's equal to 0. So now that I've set these equal to 0, a lot of people try to multiply them back together. Well, since we're trying to solve, there's no need to do that. So what I want to do is take each factor and set it equal to 0. So x plus 6 is equal to 0, and x plus 6 is equal to 0. And when I solve for x in both equations, I'm going to get the same thing. So I'm going to draw an arrow over here. X is equal to negative 6, and then the other x is also equal to negative 6. So negative 6 is my answer. That's my term that satisfies both. And if I wanted to check both values, then basically I would go back to the original equation of x squared plus 12x plus 36 and plug in the negative 6, and it should give me the same value on both sides. Of course, we've already learned how to check, so I'm going to leave that to you guys and assume that you know how to substitute in a value to check an answer. Okay, well that's all for this video. If you want to tune into the next video, I'll do a more complicated problem on how to solve quadratic equations and factor by grouping. Thank you.